Hey everyone, welcome to another video. Now, today we're going to start getting into a bit more of the nitty gritty stuff with ratios, some of the applications of ratios. And in doing this, we're going to see why this topic relates a lot to the fractions, percentages, decimals I mentioned before that would carry over to this topic. Now, today we're looking at dividing a quantity, so some amount of something, in a given ratio or in a particular ratio. So, I am going to go back to my old reliable cordial analogy for laying out these ratios. Now, what I have here is the idea that we talked about a few videos ago, where to make cordial, for example, I used the ratio of 3 to 1. So for each 3 glasses of water, I'm going to highlight this blue, I used 1 glass of cordial. And in doing this, I mixed these together and I made a big jug of cordial. Now, what I have here, I have labeled, I've given some quantity or amount to this jug, because this is going to carry over to the questions we're going to be looking at. Now, I've said this is 1 liter of cordial that I've made using my 3 glasses of water and my 1 glass of cordial. Now, these glasses are all identical. So the measurement I've used to make here, they're all identical. I've measured this with a measuring cup, measuring glass, and I've made my liter of cordial. Now, to make this a bit simpler, I'm going to convert my 1 liter into milliliters. So I'm going to say that 1 liter equals 1,000 milliliters. This shouldn't be anything new. If you've up to this point of schooling, you would have known how to convert units. And I've also talked about this in a previous measurement course. But what I want us to consider now is what we used to make up this. To make up this liter or 1,000 milliliters. How many parts or how many glasses went in to making this? So I can just count them here, that I had 1, 2, 3, and 4 total glasses that made up my whole jug of cordial. And 3 of these were water. 1 of those was my cordial, my little cordial syrup. So I'm going to consider, well, how many parts make up the whole? How many parts make up the whole jug? And we can say the jug or the whole jug is made up of 4 glasses or parts. Now, I've been very careful in my terminology here to give you a little hint, like a wink, wink, nudge, nudge, as to what we're going to be looking at. So you can probably see here the wording I've used, this idea of a whole and this idea of parts of a whole. We are now carrying over to fractions, to what we've been learning in fractions so far. And we're going to apply this to ratios. Now, I can say that 4 equal parts make up my whole. And 3 out of 4 are water. 1 out of 4 are cordial syrup. So I can say that in this whole, this whole, my jug, 3/4 of the jug is water, because 3 out of the 4 parts that went into making this were water. And 1/4 of the jug is cordial. I'm just going to call it syrup. I don't know the full name for it. But now we can look at these fractions and determine, well, how much was in each of these? What, for example, how much was, how many milliliters of water went into making this? How many milliliters of cordial syrup went into making this jug? So I can say, now I know there's a lot of writing here, but we're almost there. So 4 parts glasses equal 1,000 milliliters. I want to find out how much is in 1 glass. Well, what I want to do is I want to split up my 1,000 mils into 4 equal parts. So I'm going to be dividing this by 4. And you may see this is hopefully looking kind of familiar to what we called the unitary method in the fractions, percentages, decimals topic we talked about earlier. Now, if I divide both of these sides by 4, I've set up this little equation up here that 4 parts or glasses make up 1,000 mils, my whole. So dividing both sides by 4 gives me that 1 glass equals 1,000 divided by 4, which is 250 milliliters. So that means that in each of my glasses, there were 250 mils. So 250 mils, 250 mils, 250 mils, and 250 mils. So how much cordial was used? Well, 250 mils of cordial were used. How much water was used? Well, 250 plus 250 plus 250, or 3 lots of 250 were used. So here, how much made up my water? Well, that was a total of 750 mils of water, and my cordial was 250 milliliters of cordial syrup. This all together combined to make my whole. Now, let's actually see what we did here to find how many parts we had to divide by in the first place. Well, all we did was we added my ratio of 3 with the 1. Adding those two together, as you can see here, going this plus this plus this plus this equaled my whole. So the total amount of parts I'm dividing here, I find that by adding the 2 numbers in my ratio, the 2 or more numbers in my ratio, because the next example, we're going to look at bigger. We're going to look at some bigger numbers. Now, this is one method we looked at. This is what we call the unitary method. We've looked at this before, and now we can look at an exact same way of finding this. We're going to get the exact same answer, but just a different method. We're going to use the fraction method, and this is very similar. This goes back to what we had here when we determined 3/4 of the jug is water, 1/4 of the jug is cordial syrup. Well, we can just find what 3/4 and 1/4 was of my 1 liter, of my 1,000 mils. And we can find that, sorry, I should say. Now here, this is the unitary method. We can find this using the fraction method as well. And all we want to do here is we want to find, well, what's 3/4 of 1,000 milliliters? Now, this shouldn't be new, I'm hoping, because we've covered this in the previous video topic on fractions, decimals, and percentages. But we can find 3/4 of 1,000 mils by just multiplying this. We're finding 3 out of 4 lots of 1,000. And that, if you were to put that in your calculator, 3/4 of 1,000 is 750 milliliters. And my other one is I want 1/4 of 1,000 mils. And that I find by multiplying 1/4 by 1,000. And I get left with 250 mils. But both of these methods give us the same answer. All I want you to come out with by the end of this video is this understanding that my ratios for any question make up the parts of a whole. So these ones here, my 3 and 1, they make up 4 parts that went into a whole. Yeah, now the only thing I'm doing here is I'm applying problem solving. So I'm saying if my whole is 1 liter or 1,000 mils, how much were each of these parts? 3 and 1. Using my ratio, what went into making this whole? And I have 3 parts of water, 1 part of cordial syrup. So I had 4 parts in total. And from here, I can use my fractions or my unitary method to work out an answer. Now, let's look at one more example, and I'll give you guys a couple of extra ones that you can practice at home. But in my second example, I want to try a harder question. I want to divide $300 in the ratio 2 to 1 to 3. So I don't know, say I have $300. I want to split this amongst 3 of my friends. Now, for every $2 this person gets, another friend is going to get $1. And then another person, the third person, is going to get $3 for each $2 this person got. Now, we can rearrange the order of ratios as well. I could have written this as, 1 to 2 to 3, but it's communicating essentially the same thing. Now, I want to consider what are the parts of this? So what are the total number of parts of my whole? And my whole is my $300. Okay, well, we noticed from the last question that all we had to do was add up this and this and this. This makes up all of my parts. So how many parts do I have in total? I have 6 parts making up my 300. I have 6 total parts making up my whole of 300. So I'm going to do this using the unitary method, but you guys can also do this with the fractional method, whatever you'd like. But just because I'm conscious of time, I'm going to do this using the unitary method. So So unitary method. Center this. Okay. So I have my 6 parts make up in total 300. So I can find how much each person is going to get. And I can do that by breaking this down into, if I know 6 parts make up 300, how much money makes up one part of my whole, one portion of money here? Well, if I want to get to this, well, 6 parts make up 300, so one part would be 300 divided by 6. I can divvy this up, divide this into 6 equal parts, and doing this gives me that one part makes up $50. So I've already answered by doing the unitary method one particular bit. I've found how much this person in the pink highlighted number is going to make. This person gets one part of 300. So let me color coordinate that. So this person in the middle got $50. Now, I want to find out what the person who got 2 parts out of this whole made. And I can do that by taking what I already know about the first part, which was $50, and just doubling that, just multiplying that by 2. So I get 2 parts as $100. Now let me just check so I can color coordinate this. This is in orange. This is how much my other friend got. 2 parts. And I can find how much the person who got 3 parts got, and that I can get by multiplying my 50 here by 3, because it's going to be 3 times whatever that person got. 3 times 50, that gives me $150. And I did that one in green. Let's highlight that. Beautiful. So now I found the portions of fractions of the whole that each of these people got out of this whole $300. And I can actually just double check that that's correct, because if all of these parts made up the whole, then in theory, if I add 50 and 100 and 150, that makes up my whole. That makes 6 parts. So I should get 300. Now let's just check that. I'm going to add 50 to 100 to 150. And lo and behold, I get $300. I get my whole back. But this is how we can approach questions where, if given some quantity, if given some whole and a ratio, we can find how much each portion was, how much each element in the ratio is going to have of that whole quantity. Now, just to give you a couple of questions to practice at home. So, practice questions. The first one, I want you to divide 54 meters in the ratio 4:5. And for the second question, I want you to divide $246 in the ratio of 2 to 3. Those are the 2 revision questions at the end of the video, but hopefully by now you've gotten a bit of a glimpse into how we can start applying ratios to quantities. So when given some whole quantity that's getting split up, so for example in this question 300, or in the previous example I gave, this quantity of 1 liter, when we split it up into some ratio, we can find how much each of these, so for example, how much this 3 and this 1, how much of my whole was taken up by each of those elements in the ratio. And we always get this by just adding the elements in my ratio. Here we were adding 3 and 1. In the next question, we were adding 2 and 1 and 3. That gives us our parts, and then we can either approach it using fractions or using the unitary method. But thank you so much for watching, guys, and I'll see you in the next video.